Hi, my name is Quezon. I'm one of the solutions architect at CMI, and I specialize in power systems and system storage. I'm here today to talk about one of our client case studies where we implemented a flash and storage virtualization. So we have a client that approached us, and they have this project that they have to build a new ERP system. So they handed us out a diagram, a logical diagram of these new applications that they have to build. And they want us to provide the physical infrastructure behind it. So we went through the exercise with them and about the initial sizing, and we came up with some configurations. But one of the things that they asked for was we make sure that the number of Oracle licenses that they're paying, they want it to become lower on this new ERP system. So in order for us to do that, we needed to look at what they're doing currently on their system. So let me show you what they have right now. So currently that they have this power servers that they have here is running their production ERP system connected to the Brocade fabric, and they have all these some EMC storage back here. Okay, so let's look at this first server. This first server had like 5 CPUs, right? And it's talking to the EMC storage array, and they already had benchmarks running on this thing. So we asked for the results of those benchmarks, and we also asked for the Oracle AWR reports. Now, the Oracle AWR reports is basically a detailed analysis of the performance of the database running on the system. Okay? So after we reviewed the results, we concluded that the I/O was actually the major bottleneck in system performance. The CPU was busy doing a lot of high I/O waits, waiting for the I/O to complete. So in order for my customer to achieve the I/O workload that they're looking for, they have to actually add more spinning disks or get something faster. And that's where we introduce flash-based system. Right here. So what we did was we copied the application and database that's sitting here, and we copied those over here. And initially, the customer wants to see raw performance of this flash-based system, so they ran some tests, and they were able to get 500,000 IOPS on the system, which was very impressive. Okay, so after that, we moved on to the next workload for the normal workload, and we were able to achieve what we're looking for I/O performance, but this time using less CPU, less than 5. Okay, so what we did was we removed 1 CPU from the configuration, and we ran the same test, and we were still able to achieve the same amount of I/O. Okay, so we went through the exercise again, and we took one, another one, and another one until we only have 1 left, and we were still able to achieve the I/O that we're looking for. So basically, the flash-based system with 1 core was able to deliver the same amount of transactions compared to when it was running here on the AMC array with 5 cores. Okay, so, and that's not the end of it. So by reducing the number of cores on the server, my customer was actually able to remove 1 physical server from the initial server sizing configuration that we did, and we're able to save up to $300,000. Okay, so they were good. So they really liked the flash-based system. So they ended up getting all these flash-based systems, and we implemented the servers that they have here. Okay, so they're doing great. They actually did virtualization here, so they're doing really, really well on the server side. Okay, but now we told the customer, look, you have now 3 different flash-based systems over here. This flash-based system is by itself. You manage it individually. So let's go through an example on how to use this. Okay, so we said if this server that's running needs storage here, that's fine. You have storage here. But if this storage is running out of space and you need more storage on this flash-based system, that's doable. But there's a lot of work that needs to be done here to get that. And then you have to define the server over here and then assign storage. And that's well and good if you only have 1 server. But the customers are planning on building 100 servers, and they don't want to do that 100 times over and over. So what we told them, I said, you need some type of single management on this thing and virtualize the entire storage. So what we presented to them was a solution for storage virtualization, and we presented SVC, which is an IBM product for virtualization, and all that does, it virtualizes all the backend storage. Now, SVC is just an appliance that sits in the middle and virtualizes all your storage array. So now all I need to do is go inside each of this flash-based system and allocate all the storage to SVC, and it becomes storage pools. Okay? So now it's easy for me, since SVC is in the middle, it's easy for me to allocate storage to the system who needs storage from here or storage from here, because now it's just talking directly to one. So instead of managing each as a separate island, storage island, I manage them singular. So it's easy now to allocate storage to this, easily, okay? And the other thing was, SVC comes with a lot of advanced functions. These flash-based systems, they're really good, they're fast, and that's their job. But that's really all they have is performance. You know, some customers are looking for advanced functions, like flash copy, okay? So what if I want to do flash copy? I can definitely take flash copy from here to here. That's good, right? So SVC also gives them compression. You know, we all know that flash is not cheap. So by compressing the data, which is Oracle, by the way, they saw about 50% savings. So they were able to compress their data 50%. So now they have those additional storage on this flash-based system, okay? All right, so data migration. Let's say that this storage array is no longer, it's about 80% utilized, and some of this are like 10%, 20%, and we need to balance it out. I could easily migrate the data that's sitting on this flash base to any of these storage arrays over here without any downtime on the application or on downtime on the server side. So that's very good. I mean, they really like that feature. The other thing is the thin provisioning. So SVC provides thin provisioning, and we all know what thin provisioning is, where you can assign, for example, 100 gigs worth of data, space to here, but the server only uses 2 gigs of that 100 gigs. So SVC is really just going to use 2 gigs, again, thereby saving more storage capacity on this side. And this customer of ours have a DR side. So they're saying, okay, what can we do on the DR side? No problem. We also give them an SVC. And whatever storage array backend they have here, it doesn't matter. All we have to do is create some storage pools, and the LUNs that are here, I can easily mirror them over there. Again, it doesn't really matter what storage backend we have because SVC is managing them. Okay? So that's pretty much it. So this entire case study that we did for the customer, they were able to save costs on Oracle licensing because they reduced the number of cores on the physical server. We actually was able to remove a physical server, more than one physical server, on the entire configuration because of this. And then we were able to give them flash-based array, fast I/O access for their high I/O intensive application, and then we gave them SVC for a single point of management, plus additional advanced features that these flash-based systems never had before. Okay? Well, that's about it. Thank you very much for watching my video. Again, my name is Quezon. Please see our website for more information at www.cm-inc.com. And in that website, you can actually see our Facebook, Twitter, and Twitter links. And that's it. And by the way, we also have other CMI videos on our CMI YouTube channel, so please feel free to watch them.